All right, welcome to my week 6 problem 1 video explainer. So in this particular example, there is a cable car, and the cable has a diameter of 3 centimeters, and we are going to assume for this problem that there's uniform tension in the cable close to its maximum safe limit of 110 kilonewtons. And we're going to assume that the density of the cable is 5,000 kilograms per meters cubed. So there's going to be 4 parts to this problem. The first one is we're going to be trying to find the total mass of the cable between these two towers. So to find that, we're going to multiply that the value of its density of the cable times pi times the radius of the cable, which we were given in centimeters. So we're going to have to convert that into meters, and then we're going to multiply it by the length of the cable. So that's going to give us a mass of 1 times 10 to the 6 kilograms. Next, we're going to find the linear mass density of the cable, which is going to be equal to the mass of the cable over the length. So we just used that previously calculated mass value divided by the length of 2,831 meters, and we're going to get a linear mass density of 353.2 kilograms per meter. For the third part, we are going to calculate the speed of disturbance on the cable, and that is going to be equal to the square root of that t value. So in this case, that's going to equal to the tension over the mass. So that linear mass density is going to be, I guess, we're going to be using that for our m value. So just another calculation. So the square root of that 110 kilonewtons over the mass, the linear mass density, and we're going to get 17.65 meters per second. And finally, for the fourth part, we're trying to calculate how long does it take for a pulse to traverse the span, and that's going to be the length of the cable over the speed of disturbance on the cable, and that's going to be 160.4 seconds. So I guess just some of the tricky parts in this problem were converting some of the units, such as kilonewtons or centimeters, to the metric units, the ones that we want to use. And yeah, that was probably just like the trickiest part. And this just has to go with what we're learning in class, just about waves. Kind of just, I guess that's just like the main part. But yeah,